was your last name?
Okay.
Yeah, you're fine. Oh yeah, so here we go, 9.2. Deals with inverse functions. Let me make sure I can see that on here. Okay, also, before we actually get into the functions, I want to find the inverse of a relation. And a relation is just a set of ordered pairs. I'm going to finding the inverse of a relation. Or relationship, okay? And when they talk about a relation or relationship, they're the same. Basically, it's a set of ordered pairs. So they got a set of ordered pairs, and I'm just going to use letters for my points for now. So I got a set of ordered pairs with my X and Y values in them, okay? So when you find the inverse of a relationship, the inverse is, so we come down here. To find the inverse, all I do is switch those X and Y values so that I get a BA. This one gives me a DC, and this one would give me a FE. So all I did on those was I switch each ordered pairs X and Y values. Okay. So let me show you an example of what they give us. And we'll find the inverse of it, okay? So I'm going to find the inverse of the relation. All right, so here's what they're giving me. They're giving me the point 4, comma 2, -7, -1, -2, 9, and then 5, comma -5. So my relation is basically 4 points in there, right? So my answer, MATLAB is going to give us these little fancy brackets. We just got to figure out what's going inside of them. So notice all I did was take each point and switch them. So we're going to do the same thing right here. Switch those, I get what, 2, comma 4. Switching the next ones, I'm going to get a -1, -7. Then I get a 9, -2. And y'all finally, I get the -5, 5.
And that's the answer?
And that's what MATLAB wants right there. They're getting y'all used to what an inverse actually is. Inverses to me are opposites. Like adding has an inverse operation, which would be subtracting. Multiply Multiplying has an inverse, which is dividing. They all got like counter operations that undo them. Exponents and radicals undo each other, like square roots and all that fun stuff. So they're just wanting y'all to realize that basically we're just switching those values around when we find those inverses. Okay, so next. So this is a little bit of definition time. So for a function to have an inverse, the function must be 1-to-1. Now, we was able to tell if they were a function by doing a vertical line test. We run a vertical line left to right, and if it hit it more than once, it wasn't a function, which meant to be a function, each x value only had one y value. Well, to be 1 and 1, that means that every y value can only have one x value. So the function, x's can only have one y value, 1-to-1, y's can only have one x value. So 1-to-1 means that each y value can only have one x value. Okay? Because we said parabolas were functions that look like a big U, but y'all, that big U ain't 1-to-1 because it hits the line on both sides if I was going horizontal line. So if I wanted to have a parabola as a function and find an inverse, I would have to restrict the domain. I couldn't count all these negative numbers if I'm looking at that right side. Or if I was looking at the left side, I wouldn't be able to look at the positive numbers. So you can restrict the domain to make it fit your criteria, okay? All right. To check for 1-to-1, we use the horizontal line test. And the horizontal line test says so here's my horizontal line test, pretty much just like my vertical line test. If a horizontal line can intersect a graph more than one time, then the graph is not 1-to-1. Okay, so that horizontal line, when you're passing it down along your graph, it cannot intersect that graph more than one time. If it does intersect it more than once, it's not 1-to-1. And if it's not 1-to-1, I can't guarantee it's not an inverse, okay? So I'm going to draw some pictures and show you how I would check and see if they're 1-to-1. And then we're going to find inverses of these functions. So using horizontal line test, determine if 1-to-1. What SOLIS? Okay. So you're gonna see it. I gotta keep track where y'all are sitting in case I gotta do some of that contact tracing from the COVID and stuff, you know. So sometimes we get a few cases on campus because we got a lot of students that work healthcare and stuff, or a lot of our faculty has to go to places like the UAMS and all that back and forth. So they try to keep y'all safe. All right, so like I said, if I run the horizontal line test, it intersects more than once, it's not one-to-one. So let me draw a few pictures up here. So this will be like pictures you'll see in the question number 2 and so on. And I'm mainly just going to draw the rough graphs of these. So this one starts out getting that line right there, but y'all, this keeps going up and up and up. So basically, I was wondering if someone took my horizontal line. But y'all, I'm just going to run the horizontal line down that, and notice it intersects it once everywhere I'm hitting it on that line, right? No matter where I'm at, it only intersects it one time. Remember, we're not worried about the axis, we're just worried about that main graph. So since it only intersected it once for the most, this is yes, one-to-one. Also, I know it's a function because it's passing the vertical line test, right? So remember, vertical lines for functions, horizontal lines for one-to-one. And that's just telling me to be a function, these x values can only have one y value. To be one-to-one, these y values can only have one x. Okay. So I won't kill you with too many of these on the test, but I'll give you one because they're easy points. Okay. All right, so now that is definitely a function, but is it one-to-one?
No.
No, because if you run that horizontal line, it would hit here and here, here and here. So since it's going to hit it more than once, we're going to put no, not one-to-one. All right, let me get last name.
Tanner, T-A-N-N-E-R.
Go over here, see. Damn it. Okay. So sit them down. That's just the contact tracing if I got to later in life. All right, so one-to-one, horizontal line test can only intersect it once at the most. All right, so I'm gonna try one more. And then we'll actually play with these functions. So we're looking at relations earlier, like ordered pairs. To find the inverse of an ordered pair, all we did was switch the x and y values in each ordered pair. This we're looking for one-to-one. One-to-one means that every y value can only have one x value. So when we was looking at functions, remember the x's can only have one y. Well, now the y's can only have one x. So notice when I ran my horizontal line, this one hit twice, which means these y values had two different x's, so it failed the horizontal line, right? This one, if I run that horizontal line down it, I'm intersected everywhere on that graph one time. So this would be a yes. So all the y values only got one x value on that, okay? So now y'all got to keep up with vertical lines and horizontal lines, okay? All right, so now we're going to actually find the inverse of a function. And the inverse, the way I write the inverse function notation, will be a f -1 of x. So we're finding the inverse of a function. All righty, last name.
Foster.
Foster?
Yes.
Monica?
Yes.
Oh, okay. And you're sitting in the corner. So remember, function notation is f of x. Inverse function is f -1 of x. And we don't do nothing with that -1 like an exponent or nothing. It's just symbolism. That lets me know this is my inverse function versus my original function, okay? Sounds odd, but you'll see what I'm about to do with this. Well, the first thing, the function has to be one-to-one. So the function must be one-to-one. And I'll tell y'all, when you're doing homework and it asks you to find the inverse function, if it's one-to-one, they're all one-to-one. Other than the little graph pictures, they might be different, but we're not going to give you a lot of problems you can't do nothing too, right? So believe me, they're all going to be one-to-one. So if they're one-to-one, and I want to show y'all on the side, I'm going to sort of work through a problem while I give you these rules. So I'm starting with my function. Let me just start with f of x is going to equal something like x plus 2. That'd be a straight line, so that'd be a function. It'd be definitely a function and one-to-one both. So the first thing I'm going to do, I'm going to replace f of x with a y. Remember all along we've been saying that y and f of x are the same thing, but I can't solve it with that f of x in there. So I'm going to come over here and make that a y equals x plus 2. So I just replaced my f of x with a y. So when I took them ordered pairs earlier, what I do to those to find the inverse?
Twist them around.
I switched them around. I switched the x's and y's around. Well, guess what I'm going to do to this equation? I'm going to switch the x and the y around. So switch the x and the y. So when I switch this for the x and the y, I'll have x equals y plus 2. All right, so everything's switched. Now your job. solve that for the y that we got now. So we're going to solve for the y. Well, y'all got one move to solve that for the y. What y'all do? Subtract them two. So I get an x minus 2 on this side. But y'all, everything cancels on that side other than my y. So he's now solving for the y. My last step, and this ain't a hard step, I'm going to replace y with then f of -1 of x, which is my f inverse. So now x minus 2 equals y is the same as y equals x minus 2, right? So just realize when you got these, all you're going to do is take that y and replace it with that f inverse. And then the answer would be what? The x minus 2. Now, MATLAB is pretty nice, and they give you this stuff. All you're putting in is your actual equations on those, okay? And that's an inverse equation. You'll notice that the inverse equations a lot of times have the counter moves of these. This was adding, my inverse was subtracting, okay? So 5 little steps, y'all ready? Now, where I get y'all at on this section is the actual solving for the new y. Because it's been a while since y'all solved equations, okay? So let's see what y'all do now. Right? All right, let me make sure. So starting at number 6, they'll say, for the following function, determine whether it's 1-to-1. They're going to be 1-to-1, all of them. And then if it's 1-to-1, find its inverse, okay? So I'm just going to put find the inverse of these. So I'm just going to say 6 for this one. All right, so if you graph that x minus 6, if you was to graph it in the calculator, it'd be a straight line, which means it's definitely 1-to-1, and it's definitely a function, and all that stuff. So I'm going to find the inverse. So this one wasn't bad. First thing I said I'm going to do is replace the f of x with a y. And then I'm going to switch them so that I get x equals y minus 6. All right, now y'all just solve that for that y. So this one has one move.
Did you just add a 6?
I add 6 to both sides. So I get what, an x plus 6 equals my y. And then I said my last move was to replace the y with the inverse. There you go. So replace with inverse, that'd be f -1 of x. But y'all don't worry, MATLAB is going to give you that. All we need to put in is our x plus 6 and be done, okay? But that won't do bad. Well, now let me throw a number in front of that x and see what happens. How about this one? F of x equals 3x minus 3. It's still a straight line, so it's still going to be 1-to-1 and function and all that fun stuff. And we know that because we just got x's on these. X squared is a different story, x cubes and all that stuff, okay? So it's definitely 1-to-1. So first move. So we replace the y, the f of x with the y, and then what y'all do? Switch them up. So I get x equals 3y minus 3. Now notice, all I switched was the letters. I left that 3 right where it was at. Okay? That's what messes up people. Sometimes they put the 3x over there and the y, but you're not moving the numbers, only the variable. All right, so this one has 2 moves to solve it. We want to solve this for the y, so we need to get it by itself by adding the 3 to both sides. So I get what, x plus 3. Oh, so you must have did my last step. So I got a 3y there, we're going to divide both sides by 3. So this side you can cancel the 3's, making that a 1y. Can I cancel these 3's? No. Good job. Only way you can cancel this 3 is if both of these have a 3 in them. Because that 3 affects both of these columns, okay? So since this one didn't have a factor of 3 that I could reduce, I couldn't do nothing to it. So it's going to stay at x plus 3 over 3. And then finally replace the y with x plus 3 all over 3. So this right here is what MATLAB's wanting. So if you've ever wondered what the little -1, there's a little -1 on the left side of your calculators. See the little x -1? It does inverses, but it don't do inverse functions. It finds the inverse of a number like 5. Well, the inverse would be 1/5 because it's the inverses is flip them. All right, so let's turn it up and see what we can do on these. So those are straight lines. Well, oh, guys, we're like curvy lines, right? F of x. Oh, you know what I think I did today? Did I start at 15 after or did I start at
12.
I think I started 15 minutes early as well when y'all was coming in late. I was like, oh, everybody's late today, but no, oh man. I think I started early.
You did.
Y'all gotta keep me on track now. Yeah, because I'm used to these classes being every hour, but when you get afternoon for the evening, anything after 12 starts 12:15 and it's an hour 15-minute classes instead of 50. Okay, so we went very far in it at least. I was wondering why. I'm like, man, I'm going slow, but no, we started early. Okay. All right, y'all. F of x equals x cubed minus 8. And Roscoe's fault, he was in here like at 10 till, making me think I started at 11. Over there at 12. Oh, your fault. All right, so that is a cube, but guess what? It is definitely going to be 1-to-1. So, lead me to it. Replace the blank with blank.
And you flip the x and the y.
Now remember, that 3's got to stay here, so we're going to get x equals y to the 3rd minus 8.
So
Now, since you got a cube in that thing, you really want to get that y to the third by itself on this problem. Okay, so let me show y'all. I'm going to recall y'all on radicals real quick. So if I had something like x to the cube equals some number, the way I solve this, to undo exponents, I use radicals. Okay, so radicals will undo exponents. But if I do the radical to this side, then I got to do it to the other side. So that this radical cancels that exponent 3, so that I get an x equals a cube root of a, okay? Also, what if I had a cube root of x equals some a? And I want to solve this for this x. Well, if radicals undo exponents, then guess what? Exponents are going to undo the radicals. So what I'll do is raise each side to the third power. And then that would equal a to the third power. So this exponent now cancels the radical, and you're left with x equals a to the third. So remember, exponents, I take roots, I get with exponents. Okay. So now back to my problem. I need to get that y to the third by itself. So what move?
Cube root.
What first?
Oh,
And mate, there you go. So y'all notice I get an x plus a equals my y to the third. Now I'm definitely going to
cube root.
hit it with that cube root. So each side, I'm going to cube root. Because it had a y3, I needed to hit it with the cube root, but since I did that side with the cube root, this whole side had to go under the cube root too. Well, I know the right side, y'all notice, exponents canceling with the radical, giving me just a y. Can we do anything to this cube root of x plus a? No, I can't do nothing to that, so that's going to stay a cube root of x plus a. So, since these things are basically undoing each other, when you find the inverse of a cube, it better have a cube root sitting there, okay? Oh, I forgot my last move. There you go. So f equal 1 to x will equal the cube root of the x plus a. Okay? I always sort of thought these were fun because they wasn't too bad. Oh, now I will say next week is the week to come to class. Because we're going to solve systems of 3 equations. Now, hopefully y'all have seen systems of 2 equations before. I had like an x plus y equals 10, and then under it, 3x minus 2y equals 5 or something.
Oh, yeah.
And y'all solve them by elimination or substitution or something like that. So we're going to jump up to 3 equations with 3 variables. We're going to be solving for x's, y's, and z's next week.
Next Wednesday or Monday?
Monday and Wednesday, because Wednesday that does the word problems, but it's the same thing. You just got to figure out what the numbers are.
Can we come to both classes or is it just one?
Oh, I've had some of y'all were here Monday. We were sort of full Monday.
Yeah.
I was right at 12, I think, wasn't I? So I had one for one more. But you're going to see the longer the semester goes, it's going to thin out a little bit more. I'm going to have to start sending out bad emails probably, you know, threatening people. Or you remember in the syllabus it had a participation grade was 10% of the class. So if they're slacking too much, I'll just start putting in bogus grades. And Well, why's my grade going down? Well, because you ain't coming to class or something, you know?
Oh,
I'm not real strict on it, but they can't be on there doing nothing because they're just wasting their time.
but if we're not here, we can use the Zoom, right?
Oh, yeah. So if you ain't here in class with me in live, then I got, looks like 3 of them online with us, or 4.
And we'll get credit for
Mhm.
participating.
Oh, they're just not showing up, and they even ask questions on there if you want to. I've had some of them saying stuff already, right?
Is it gonna hurt me that I don't come on Monday, or on Monday?
No, just do homework. So here's what I look at. I sort of look at my attendance, and you'll see that, I don't know, if, like when people are missing, I don't know if it's sending emails out or not. It used to do that automatically. But in the portal, you should be able to see like attendance for your classes and stuff. I mainly look at the attendance first, and then I'm looking at my slackers, who's missing. I'm gonna go look at their grades. Are they doing my homework? Are they keeping up with it? If they're keeping up with it, I usually don't have no issues with it because they're probably watching my videos and learning it that way. I don't even mind that, just watch the videos whenever that I'm sending y'all in the emails. But if they're sort of not doing that work and they're not showing up, then I gotta penalize them. So instead of getting a 10 for participation, they might get a 6 or a 7, which ain't a lot of points, but in the long run, it can drop.
Yeah.
10% of a grade can drop in a letter grade. Okay, so the ones that ain't doing nothing, I'm gonna start putting in a grade for y'all. I mean, y'all mostly are, if you're coming 1 of the 2 days live, I'm happy with that. Okay. But I got people I ain't even know what they look like in this class. I don't see them online, I don't see them in live person, right? So I'm like, who is this person? So, and then I look at the only thing they've done in class is the course agreement quiz. They kept them in class, but now they're being hurt because they're not doing nothing, so. We gotta figure all that out, right? And it don't matter which way to go, because if they're slackers, I get hit the same way if they get an F as if they was withdrawn. Does that make sense? It still ain't what you call it, it's not success. If they want all the congressmen want schools to be successful. So if they ain't really successful, they start holding your funding and stuff. So we try to give them every chance we can, y'all. I mean, I've had some I've dropped in my Caribbean email me. Is there any way we can let this student back in? They promise they'll do all this work. What do you think they do?
Yeah.
When you're half a year behind in college algebra, it ain't something you can just spit out, So I always tell them, well, I mean, if you want me to do it, I'll do it, but I don't feel real confident, I go, square root of x minus 4. So if you were to graph that, it would be a nice little graph that sort of goes to the right, like square root graphs do, but it's still 1 to 1. So since it's 1 to 1, I'm going to find that inverse. So let's start off by replacing the f of x with a y. And then I'm going to switch them up. So I'm going to get my x equals a square root y minus 4. Now, one thing you cannot do right off the bat on this one, and I had to get someone earlier, is you cannot add 4 to both sides of this. That 4 is under the radical. That's not really a 4. That's the square root of y minus 4. But you can't add 4 to both sides since it's under the radical. Your first move, get rid of that radical. So how am I going to do that? Square both sides. Now remember, radicals without numbers really got 2's there. So we're going to square both sides. So this x squared comes down. And by him squaring that radical, we just eliminated the radical And on its left is the y minus 4. You got it?
I did get it.
Okay. No radical left, 1 new,
Add 4.
add 4. So it looks like I'm gonna get what, an x squared plus 4 equal to my y. So the hard part's done, now I just wanna replace it with the f inverse, okay? But notice these, radical ended up with an exponent, exponents end up with
Radical.
radicals, okay? Oh yeah, let me catch up with it. We said we had to make that an f negative 1 of x. So the math lab wants that part right there, okay? Now we'll say, test 2 material, we start getting into all the factoring and stuff like that, quadratic formula stuff. That'll bring back more memories than probably what I'm doing now. All right, so unfortunately, I just got one more.
Yes, Lord.
So this one gives me f of x equals 7x squared plus a 2, and then it's got an x greater than or equal to 0. Now, let me show you what this is. This is the problem right here. What this is telling me is that we don't want no negative x values. We're only looking at the positive x values. And I'm going to show you why they're doing that. So if you was to graph this, which I'm not going to officially graph, but if you was to graph this, you would end up with a parabola like that, okay? Which at the moment, that's not 1-to-1. Because if I run that horizontal line test, I'm hitting here and here both, right? That's why they did this. They're saying, hey, we only want to look at your graph for x values from 0 to the right. We don't want no negative x's here. So they're not looking at negative x's, which means they don't care about the left side of that graph. Okay? So if I restick that domain from 0 to infinity, is it now 1-to-1?
Yeah.
Yeah, because I don't have to worry about this side no more, and this side passes it. So remember, this is just telling you what the domain for the x's is, okay? And other than that, we're done with that x greater than or equal to 0, okay? Now, we're just going to focus on this f of x equals 7x squared plus 2. So, I do have an x squared in this one, so I'm expecting a what in my final answer?
Square root.
Square root, okay? Because remember, they still undoing each other. It's just getting to it's going to be the trouble on this one. So, here we go. Let's make that a y equals 7x squared plus 2. So first thing you're doing, switch them around. So this is where you got to leave everything on that side other than the x. So that'll be now a 7y squared plus 2. And actually, I think on this one, in MATLAB, they give you most of the answer except for the top part of the fraction. And I'll show you what I'm talking about when I get this one done, okay? All right, you're going to solve that for the y squared. So first of all, you need to get the 7y squared by itself. I need this by itself. Minus the 2 over, there you go. So you now have x minus 2 equals 7y squared. And I still don't like that 7 in front of that y squared. So move it by what? Mm-hmm. So I'm going to divide both sides by the 7. But notice on this side, we can cancel out our 7s. So I'm going to move up here to right the rest. So if I cancel these sevens, I'll get an x minus 2 over 7 equals a y squared. So last move, square roots. So square root x minus 2 over 7 equals square root of y squared. So y'all know that side's gonna be a y. Can I do anything with that square root? X minus 2 over 7.
No.
I think it's done.
I'll answer. What'd y'all say on there?
Yeah, I think it's done. That's square root of.
Say what, X minus 2 over 7. Now in the math lab, they're going to do this. They gave you this, and they give you that. All you got to do is figure out what went on the top of that answer, which I would put a
X minus 2.
X minus 2. So that one, they gave you most of it, I guess, to help you out a little bit, because it had all that dividing and the adding and subtracting and then the radical. Okay. Questions on those? They're not too bad. Yeah, not too bad at all. So, yeah, I started 15 minutes early, so I'm about 15 minutes over, did it? Well, any questions out of y'all? This ain't too bad. Just remember, replace, switch, solve, throw that F and negative 1 in there and be done with these things, okay? So I'm just gonna keep it mild today. That way next week we can do the 3.5 stuff. So what we got next week is the chapter 3 stuff. 3 sections, they're not too bad. The last 2 are really easier. 3.6 and 3.7, I think it is. And then the next week is the test week, right?
Is it?
So how I'll do the test, so next week will be the 3 stuff. The next week after, I will review one day for the test and open that test up, and it'll be open until Sunday night for that week. So I don't give y'all like one day to do them because people work and then some people do different things. So I just leave it open. I'll review and then I'll open it until that Sunday night. Okay. But remember, tests got to be done by due dates, or they get zeros put in there. And the only way to switch that would be on the final exam. I would switch one low test with my final. Okay. So tricking this class is starting good.
Yeah.
I get some that start like 30s and 40s on their first test, because they don't stay. Y'all 30s and 40s is hard to.
I know.
But I got one test in the future that's a little tough as far as a lot of work on them. Even if you're at home, it's still tough. So you want to start good in here. And the main thing y'all want to get those hundreds on all those homeworks. Like me and you was the other day, we was able to go back in and redo all the ones we wanted to. For anybody can go back in and redo any homework assignment. You want them to be hundreds because you control that. The quizzes, you can do them as many times as you want. And the only quizzes I give y'all are quizzes for your test. It's a study guide that looks just like my test. And the reason that's the only quiz I give y'all is if you do good on that quiz, you're going to do good on my test. All I do is change a few numbers on them, going back and forth. You know, it generates whatever numbers. So if you make 100 on a quiz, by God, you ought to make 100 on my test. Okay? Quiz gets, you can do the quiz 1,000 times, but the test, one.
Why does when you do your homework it doesn't save?
Anytime you're into homework and doing it, if you get off of it, it's going to keep what you got up to that point. So if you do 3 problems out of 10, it's going to grade you at 30% at that moment. And then once you click back into it to do it again, just pick up from where you got the red X's.
I was doing something last night and my computer shut down because I left it. And when I came back, it's like I had to start all over again.
They should be real-time grading, which means if you do one question and get it right, no matter what, it should have that in the system as being right, and then you'll be going on to the next one. So make sure you're make sure when y'all are doing homework, when you first click into the homework to go to them, make sure it says you are improving or changing the grades. If you go in there and just do review,
Oh.
if you click the review and go into that, you can do them problems all day long, but it's not changing the grade because it thinks you're just reviewing. You want to physically tell it, hey, I want to improve my score or whatever, click on that button. And if you're in that mode, it's going to save everything you do to it. Because I've been on it, practicing and been knocked out by storms, but when it came up, everything that I actually had submitted as a, once you hit the button and check it, it's basically submitting that for you at that moment. Now, also remember this. If you look at one homework assignment, just to see what it looks like in there, once you click it open, guess what? It's real-time grading at that moment. So if you look in there and say, oh, this has got some scary problems, and then click back out of it, guess what it just put on your grade? A 0 because you didn't do none of the problems yet.
Oh. Could you go?
It'll let you change them back, but if you open up too many assignments and get 0 put on it, although you're making hundreds on everything, your score ain't going to be 100 because of all these zeros that's kicking in there. I had people do that the whole year. They would click on stuff just to see what it was like. Oh, Ms. Rev, I do good on this problem, but my grades are bad. And I'm like, I don't know, let me look. Oh, well, what's all these zeros? We didn't cover this material. What's on it? Oh, I was just looking ahead. Oh, well, your grade will be jacked up until you get down to about eliminating a few of these zeros out of there, you know, and then not fixed in, you know, but it's real-time grading. And also remember, although Math Lab is real-time grading, Blackboard might not be accurate as quick. It takes it a little bit of time sometimes to sync in grades into the Blackboard. So you might do a homework assignment and be like, got it from 70 to 100, but you went to that Blackboard, it says 70 still. Don't freak out. It'll sync over eventually. Sometimes it does it quick. Sometimes it might take an hour or two to get them synced over. But it catches up eventually. Yeah. So that's one of the issues I got with them is it sort of goes slow sometimes syncing them. And sometimes I think putting a grade book in MathLab and Blackboard is confusing, you know, because all my due dates, if I modify one section, it won't trickle into the Blackboard. It's like stuck on the original due date. So we don't like that aspect of it, but I try to follow my schedule. So we only had 9-1 and 9-2 this week. So guess what? That's all we're doing, right? We'll play with the Dream stuff next week. So all those fun equations, okay? So I don't have anything else. So y'all got any questions at all? So everybody should be certified. That means I have submitted y'all as being in class. So since I have submitted y'all as being in class, your financial aid will roll on through whenever it's ready. So any of y'all getting financial aid? Man, y'all must be pretty rich, man. When I went to school, I lived on loans and grants, and I come from poor side of Southwest Little Rock, off the Guyer Springs area, if y'all know where that is. So,
Are we going to support flag?
do you need it? Huh? Okay, so get over there. So I can probably stay over there 20, 30 minutes. And then I got to go. So my wife's getting a shot, her second shot or whatever. Second one?
Yeah.
Did you have both of them already?
Yeah, I need like my skin bubble.
Because where do you work at? Because you're healthcare, right?
Advanced pathology solution.
Okay. I got to get my second one in about 2 weeks, I think it is, whatever the 19th or 18th is.
Yeah, it hurts. It hurts bad.
You didn't get sick after it or nothing?
I didn't, but I know people did.
Really?
Yeah, and like I'm not kidding. Like it made my shoulders break out. Like each one of them broke out.
Oh, no.
I took a shot, and then cause I got these better shoulders.
Oh, you took one on one side and the other?
Yeah, and I mean it was sore for like 4 days, and it was like twitching out. My shoulders were, like, twitching out.
I did one Friday, the second one, I'm like,
Yeah.
well, the first time, my first one, I just felt like somebody hit me with a
end up
baseball,
doing
so
some
it lasted
like,
like 4
and
to
it
5
still
days,
didn't
and I was
stay.
like, gosh, this
but I don't know if.
Yeah, I say.
Okay, so let me pull you up here. I think I can get much quicker
I
here.
hate trucks.
All right, y'all, so I will see y'all Monday.
Come over here, look up here.
Oh, I don't know if that'll play my actual desktop, but I'm gonna try. All right, y'all, I'm just trying to catch a few of these names real quick. Amelia Clark. Yeah, down that way, right above, well, it's not real far, about where the Coke machines would be. All right, y'all got everybody online, so I will see y'all come Monday.
I'm gonna go across the street, I mean.
But me and you gonna play here real quick.